Hello everyone. So today's video is focused on finding the general term of a quadratic sequence. This is most relevant to the IB/MYP criteria B, which is about patterns, and criteria C, which is about communication. And communication involves correct mathematical terminology and correct notations and symbols. For a quadratic sequence, you may have seen such examples for a general rule like 2n squared minus 5n plus 3. As you can see, the highest power is 2. So such a general formula is called the general formula of a quadratic sequence. Or in other words, the sequence that this formula will generate will be a quadratic sequence. Let's take another example. Now in this example, the highest power 2 is not explicitly available to us. So we may have first simplify and then see what is the highest power involved. Again, the highest power involved is 2. Hence, this is also an example of a quadratic sequence. Now, I have chosen this quadratic sequence on a very random basis. It is 2, 9, 20, 35, 54, and so on. In this video, we will have about 3 different methods, and I'll share all 3 methods with you. And there is no hard and fast rule which one is the better one. Any of these methods could be your preferred one. And at the end of the video, I will share which one I like the most to use. So the first one involves solving simultaneous linear equations. I'll write these numbers here: 2, 9, 20, 35, and 54. Let's check the differences. So 2 is added to 7 to make it a 9, and then 9 is increased by 11 to make it 20, and then you can see that the numbers that are being added are not fixed numbers. They are changing themselves. Similarly, this is 19. We call these as the first differences. Now, had it been the first difference be a constant, we would have called it as a linear formula. It means the highest power would have been simply 1. But since the first difference is not a constant, so it's not going to be a linear. Let's check if its second difference is same or a constant. So 7 is added by 4, increased by 4 to get 11, and then 11 is increased by 4 to get 15. So you can see that now the second difference is a constant. If the second difference is a constant, then this is going to be a quadratic sequence. And for a quadratic sequence, the general way of writing any quadratic sequence is an squared plus bn plus c. And now our job is to find these letters A, B, and C. Out of these 3 letters, A is the easiest to find. For A, it's simply the half of second difference. In this case, the second difference is 4, so we have already got the value of A. That is 2. I'm going to update this equation. Let's call it the star equation. Now we have A is equal to 2n squared plus bn plus c. And let's call it our equation number 1. Now we still have 2 more variables to find. Now if we have 2 variables, we need 2 equations, and then we will solve them simultaneously. So how do we get those equations? I'm going to see the information here. When n equals to 1, your first term is 2. So let's plug in the values. N equals to 1 everywhere here. 2 times 1 squared plus b times 1 plus c. And we know that when n equals to 1, the first term of the sequence is 2. And we simplify that, we get 2 plus b plus c is equal to 2. This cancels out, and our first equation that will help us to find the values of b and c is this. This is equation number 2 in our list. And then let's check another one. When n equals 2, the term is 9. So we'll use this information. I'll replace n equals n by 2 everywhere in the general formula. We have 2 squared plus b times 2 plus c. And we know that when n equals to 2, the term is 9. So we have 2 times 4 plus 2b plus c equals to 9. And this results in b plus 2b plus c equals to 1. And let's call it equation number 3. Now we've got 2 equations, equation number 2 and 3, which are involving b and c, and we will solve them simultaneously to get their values. B plus c is equal to 0, and then 2b plus c is equal to 1. Upon subtraction, c cancels out, and we are left with minus b is equal to minus 1. This results in b equals to 1. Now, once we have found the value of b, we can use either of these equations 2 or 3 to get the value of c. So I'm choosing equation 1 for that. B plus c is equal to 0. Easy number to solve it. B is 1, and this gives us c is equal to negative 1. Now I've got all these three unknowns at the start. I've got A, I've got B, and I've got C. And so the general formula for this quadratic sequence will be 2n squared plus 1n, but I won't write this one. So you simply write n is minus 1. So this is our general formula. Now make it a habit of that whenever you find a general formula, you at least test it for the values that you already know. Let's see if our rule works, and this time I'm going to use n equals to 4. So let's test it for n equals to 4. We should get 35. So when n equals to 4, I'm going to replace n by 4 everywhere. 2 times 16 plus 4 minus 1 is 3. 2 times 16 is 32. And 32 plus 3 is 35. So A4 is 35. Hence tested. I'm not going for further command terms like justify or verify. So we are just testing. Okay, so I'm going to discuss the next method. And next method is quite interesting in that regard. You may have to remember a few facts, which I'm going to list here. As in the previous method, we will take the first difference, which is not a constant. So we check the second difference, and which happens to be 4. And our general rule is an is equal to an squared plus bn plus c. And this a, the coefficient of n squared, is always found in the same manner in all three methods. The value of a is the half of the second difference, which is 2. So we can write it here. An is equal to 2n squared plus bn plus c. So I got this equation as the most updated equation so far. You have to remember these two facts. The first fact that I'm going to tell you is 3a plus b is difference of first two terms. We don't want to go into the proof of this, so I'm just asking you to remember this, that 3a plus b is the difference of first two terms. The first two terms are 2, 9. So the difference of these two terms will be second minus first term is 7. So I've said 3a plus b is equal to 7. And already I've got the value of a. So 3 times 2 plus b is equal to 7. And this gives us b is equal to 7 minus 6. Hence b is equal to 1. Now the second fact is a plus b plus c is equal to the first term. We've got the value of a, which is 2. We've got the value of b, which is 1. And so c is equal to the first term is 2. So here we are. 3 plus c is equal to 2. And this gives us c is equal to negative 1. And there we are. We have just found the values of all three unknowns. So we have got an is equal to 2n squared plus b is equal to 1. So that's 1n written as n only. And c is negative 1. So that's our general rule. It's quite interesting. You just need to remember these facts, that 3a plus b is the difference of first two terms, like the second term minus the first term. And then the other fact that you have to remember is a plus b plus c is equal to the first term. And this gives you all three unknowns. Okay, so in this third method, we again have the original sequence to 9, 20, 35, 54, and so on. We take the first difference, which is 7, 9, 15, and 19, and so on, and the second difference 4. Since the second difference is a constant, hence we know that it is going to be a quadratic sequence. If it is a quadratic sequence, then its general term is an is equal to an squared plus bn plus c. And as before in the other two methods, we find the coefficient of n squared, which is a, by taking the half of the second difference. So the second difference is 4, and the half of that is 2. We know that a is the coefficient of n squared, so we'll make another sequence, let's say bn, which is 2n squared. And now we will find the values of, let's say, first 5 values of this sequence. So when n is equal to 1, these are the values of n. So n is equal to 1, 2, 3, 4. And what does bn give you? It's 2n squared. So 2 times 1 squared is 2. 2 times 2 squared is 8. 2 times 3 squared is 18. And 2 times 4 squared is 32. Right, so we've got two sequences. One sequence was the original one. Then we found another sequence, which is made by just finding the value of a, which is the coefficient of n squared. So that's our next sequence. I'm going to write these two sequences. The original one is 2, 9, 20, 35, 54, and so on. And the sequence that we generated now is 2, 8, 18, 32, and so on. I'm going to take the difference of the two sequences. So 2 minus 2 is 0, 9 minus 8 is 1, 20 minus 18 is 2, 35 minus 32 is 3, and so on. And now we've got another sequence. Okay, so now we have another sequence 0, 1, 2, 3, and you can see that it is obtained by adding 1 to the previous term. Its first difference is 1. If the first difference is a constant, we know this is going to be a linear. I'm going to say that this is another sequence Cn, which is Cn is equal to a1 plus n minus 1 times t. D is the common difference, and which is 1 in this case, and a1 is the first term, which is 0 here. So we plug in the values. Cn is equal to 0 plus n minus 1 times 1, and hence this new sequence is n minus 1. Now we've got the sequence Cn, we've got the sequence Bn, and we started off with An. And we just said that An is equal to the sum of these two new sequences. And so we have 2n squared plus n minus 1 as the general rule. And hence this is another way of finding the general term of a quadratic sequence. You can use any other example and give it a try, and then decide which method suits you best. And as I mentioned, that I will share you the method that I prefer the most. If I can remember these two facts, I would definitely prefer this method. So you might want to go with that method which suits you, and you can always recall that.